These are some of the questions asked in this about this page replacement algorithms. Optimal, first in first out, and least recently used. I have given all the questions. These are the main models given. This question is asked in GATE 2014 and 95, GATE 95, GATE 2009, GATE 2007 and GATE 2014. So what are they ask? What are they saying is they are saying that demand paging is used. So demand paging means initially when you start the process, no pages are in the main memory, right? And then page faults are going to happen. So they are going to ask us, they are asking us how many page faults are there. So what is a page fault? Whenever you refer to a page and if the page is not present, then that is a page fault, right? So they are saying that demand paging is used for all of them and page faults are going to occur, and how many page faults are there, they wanted to count. So they have asked this question for only one algorithm, like either for FIFO or LRU or optimal. I'll take each question and solve for all the three models. That way we can practice more. Okay. And now one more thing. Okay, let me start it. So whenever this is called as reference string, right? So in all the reference string, whenever they say 4761 like this, they mean to say they are the page numbers, right? So let's solve the question number 1. It is asked in GATE 2014. You can read the question, complete question in any question paper. But anyway, this is a summary. They are giving you this as a reference string and these many frames are available. And using these many frames, we are supposed to run the algorithm and find out how many page faults are there. Okay. So what is it? It is 4, 7, 6, 1, 7, 6, 1, 2, 7, 2, right? So now assume that there are 3 frames. 1, 2, 3. 3 frames are there, right? And now all the 3 frames are empty. Whenever we refer to the page number 4, page number 4 is not present. Therefore, I am going to take page number 4 and place it here, right? I am here. And next, I will be looking at page number 7. And page number 7 is not there, therefore I have to get page number 7 and I can use this one. So no replacement as of now. As long as we have free frames, we are not going to replace it, right? And what about this? Page number 6 is referred and there is a free frame, therefore no replacement. And next one is page number 1 is used. So now we have to get this replacement into picture. Now assume that we are using optimal page replacement algorithm. Okay, so if we are using optimal page replacement algorithm and we are referring 1, now there are 4, 7 and 6. These 3 are present in the frames in the main memory. You have to replace one of them. Which one are you going to replace? Optimal says that you look at the future and in future whichever is not being used for a longest time, you replace it. So in future if you watch it, 7 is going to be immediately referred and then 6 is going to be referred, but 4 is never referred, right? Therefore you can replace 4. Simple, right? You are here and you want 1 and you want to replace one of them. Now you look into the future and whichever is not going to be referred for a long time, you replace it. Now it is clear that you are not going to use the 4 anytime. So you are going to replace 4 with 1, right? And next 7 is required, 7 is there. That is the advantage. See, by looking into the future, you are not going to get 2 successive page faults immediately, or at least if a page is already present, you are not going to take it out. Okay, please don't take the last statement. What I mean to say is, if a page is already present in the main memory, you will not replace it if it is required immediately, right? That is what happens with optimal. Now 7 is required, 7 is already there. And then 6 is required, 6 is already there, and 1 is required, 1 is already there, right? And now 2 is required, right? And which one are you going to replace? I have 1, 7 and 6 and now I need to get 2. Which one are you going to replace it? You are not going to replace 7 because 7 is required immediately, but you could replace either 1 or 6. Which one do you want to replace? You can replace any one. Let us say I am replacing 1 with 2 because 1 is not used in the future or 6 is not used, therefore I can replace anything, right? So 2. Now when I replace it with 2, next one is 7 is required, 7 is there, 2 is required, 2 is there, right? Now we have to compute the number of page faults. Now how can we compute the number of page faults here? So every number I have written down here is a page fault, isn't it? because if it is not present, initially it is empty completely, and therefore every time if I have to write a number here, that will happen only after a page fault. Therefore the number of numbers I have written here is equal to the number of page faults. Theoretically you could do it, right? Practically you might have to have a counter and then write a program, but theoretically you can, if you're looking at it, it's just a theoretical question, right? So every number I write here is a page fault. The reason is initially these are not there, and the only way I get them here is by page fault, right? So look at this, this 4 1 time 1 2 3 4 5, so page faults equal to 5. In optimal, page faults equal to 5 for this sequence. Got it? Now let's see what happens if I use LRU, least recently used, for the same reference string and for the same number of for the same reference string and for the same number of frames. Let's see how LRU works. LRU means least recently used. So now we shall start with this. Initially 4 is not there, so 4 will be here. 7 will be loaded. 6 will be loaded. No replacement as of now. Now we have to replace 1 because we need 1, but we don't have this. So which one are you going to replace? So in this case, what LRU will do is LRU will try to see the past and it will try to guess which one to replace. Now see this, if you are standing here and just look at the past, which is the least recently used? So 6 is most recently used, and second most recently used is 7, least recently used is 4. Therefore you have to replace 4 first. So 4 is replaced, right? And next 7 is required, 7 is there. 6 is required, 6 is there. 1 is required, 1 is there. Now 2 is not there. Therefore, not to get 2, which one are you going to replace? Again, look at the past. Past means if you are standing here, look at the past and see which one is least recently used. Which one is least recently used here? Now here it is 1. See, so 1 is most recently used, second most recently used, 7 is the least recently used, isn't it? Therefore replace 7 and you get 2. Now the problem is immediately after replacing 7, I need 7, right? And now which one do you want to replace? Again, look at the least recently used. So 2 is most recently used, 1 is second most recently used, 6 is least recently used. So you replace it. So you replace it with 7, got 7. And next one is I want 2 and 2 is already present, right? So in case of LRU, least recently used, see what is the number of page faults. Every number I write here is a page fault. So 1, 2, 3, 4, 5, 6. 6 page faults are there in LRU. And now let's see about FIFO, first in, first out. So first in, first out, you have to maintain a queue. So in the queue, whichever has entered first, that has to leave first, in case if you want to replace a page, right? So along with the frames like this. So initially, I'm even going to maintain a queue. Queue will tell me which one to replace when. Okay. So now 4 is not there, so 4 is loaded. 7 is not there, so 7 is loaded. 6 is not there, so 6 is loaded. And now what is the, even you have to even maintain a queue. In the queue 4, 7, 6, this is the order in which they entered, right? Now queue will say which one has entered first and which one has entered last. Therefore the first one which has entered has to be replaced, right? So now next one is I need 4. So if I need I need 1. So if I need 1, which one you have to replace? So you have to replace the first one which has entered, which is nothing but 4. Therefore replace the first one, right, which means this one, and now 1. So 1 is going to enter here, right? Now in the available frames, which one is the first one to leave now? 7 has to leave next, in case if it is required to leave, right? And next one is 7. So now 7. So watch, 7 is already there, therefore no replacement is required. What about next one? 6. So 6 is already there, therefore no replacement is required. And what about next? 1. 1 is already there, therefore no replacement is required. And what is next one? 2. So 2 is not there, so you have to replace it. Which one are you going to replace? You are going to replace the first one which has entered, right? So which has entered first one? That is 7. 7 has entered first. In the available one, 7 has entered first. right? Therefore 7 has to be replaced, 7 has to be replaced with 2, and 2 is going to be kept in the queue, right? So now in the available queue, which one has to leave next? 6, right? Now I want 7, 7 is not there, which one has to leave? Now in the availability, 6 has to leave first, therefore 6 has to be replaced with 7, and 7 will enter the queue, right? And next 2 is required, but 2 is already there, isn't it? So now what about FIFO? So for FIFO, here first in first out, the page faults are 6. Understood this? So now if you observe it, optimal is giving the least, and then these two are giving equal, but here we got it as equal. It is just a coincidence. It doesn't mean that we'll always get equal, but one thing is for sure, optimal will give as minimum page faults as possible, or no other algorithm can beat optimal. They might be equal, but it can never beat optimal. Okay, fine.